In this lesson, we're going to learn about different types of angles, and also we're going to be learning about how to find the midpoint of a line segment and what that means. So let's start with the title of our lesson. The title of our lesson is Midpoint and Parallel Lines. So I'm going to type midpoint and parallel lines. And we'll start with some vocabulary. Bisect means to divide into two equal parts. So you can bisect an angle, you can bisect a line segment. That just means that the two parts will be congruent to each other. A midpoint is the exact middle point of a line segment. So when you bisect a line segment, you are creating a midpoint. Parallel means that you have two continuous lines that never meet. Perpendicular means that you've got two lines that intersect to form four 90-degree angles. And let's slow down and talk about these last three definitions. A transversal is a special type of line. This is a line that passes through two lines in the same plane at two distinct points. Okay, so I'm going to draw a picture of what a transversal looks like. So you should have, here's an example, you should have two lines and then another line that passes through those. And this other line is called the transversal. Corresponding angles are angles located in the same position on two lines cut by a transversal. And I will draw an example of what that looks like. Okay, so for example, if you see two lines cut by a transversal, and I can certainly label these, give them numbers, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, the ones that are in the same position, I like to think of this as two windows. You see how there's 1, 2, 3, 4 panes in this window, and 1, 2, 3, 4 panes of glass in this window, kind of like a window. And you've got two windows, and the corresponding angles are the ones that are in the same position compared to each other. So for example, this upper left-hand pane of a window and this upper left-hand pane of this other window, angle 1 and angle 5, those are considered corresponding angles. And if these two lines are parallel, see this little arrow I drew? That's a symbol to show you that they're parallel. If the lines are parallel, then the corresponding angles are actually congruent to each other. So in this case, angle 1 is congruent to angle 5. Okay, alternate interior angles are very, very similar. So these are angles on opposite sides of a transversal inside the two given lines. Okay, so they're opposite, that's the alternate part, and they're inside, that's the interior part. That's how you can remember what this is. And I'll show you what I mean. Here's an example. We'll draw the same sort of picture we drew above, but we're going to identify different angles this time. So I have angles 1, 2, 3, and 4 5, 6, 7, and 8. Okay, so let's pretend the two lines are parallel. And then we're looking for inside. Okay, so there's 4 angles inside. 4, 3, 5, and 6. They're inside these two lines. And the ones that are on opposite sides of the transversal, 3 and 5, those are alternate interior. Angle 3 and angle 5, they're congruent because these two lines are parallel. Same thing is true of angle 4 and angle 6. They're also considered alternate interior angles, and they're also considered to be congruent to each other. So let's look at some applications of the vocabulary. Example 1 says, use the number line to determine whether each statement is true or false. If the statement is false, rewrite the statement to make it true. So we'll start with A. This says R is the midpoint of AB. So first find R and then find AB. Here's R, here's AB. R is obviously not in the middle of AB. 1, 2, 3, 4, 5, 6. AB is 6 units long, and R is 1, 2, 3 located here, 4 units away from A. So the midpoint would actually be M, which is located at 2. So I'm going to say that this is false. We'll say M is the midpoint of AB. Okay, the next statement says NA is congruent to AM. So find NA, find AM, and compare them. They don't look the same to me. I'm going to count here. 1, 2, 3, 4. NA is 4 units. 1, 2, 3. AM is 3. So I'm going to say this is also false. NA is congruent to AR. AM is not long enough. So NA is congruent to 1, 2, 3, 4. 1, 2, 3, 4. They are both 4 units wide. Okay, MR. Let's erase this again. Is MR congruent to TM? MR, TM. They're both 1 unit wide, so yes, this is true. And then the last one says A is the midpoint of NM. A and NM. Here's NM. A is here. Is that the middle? 1, 2, 3, 4. 1, 2, 3. No, it is not. This is also false. A happens to be the midpoint. A is the midpoint of N. Let's see, 1, 2, 3, 4. I have to count 4 more here. 1, 2, 3, 4. NR. Okay, so we're just looking for the middle for midpoint. We've got 2 more examples and then a couple of practice problems to look at. So let's go on to example 2. Example 2 says find the measure of angle 1, find the measure of angle 2, and then justify each of your answers. Okay, so I see some vertical angles and I see some corresponding angles. So we can start with the measure of angle 1 is equal to 120 degrees because angle 1 and the 120 degree angle are vertical angles. You can keep going if you want. You could say, and vertical angles are congruent. But I'm going to stop there. And the other answer is the measure of angle 2 equals, this is 120, 120 degrees. Because angle 1 and angle 2 are alternate interior angles. And alternate interior angles are congruent when lines are parallel. So these lines are parallel. So these angles that are inside the two lines and across from each other, opposite sides of the transversal, they're congruent. So we've answered the two questions. Example 3 says, find the value of the variables in each figure. Explain your reasoning. So I've got x and I've got y. I have to figure out what those measures are. I can start with 4x degrees and 7x minus 78 degrees are corresponding angles, which means they are equal to each other. They're congruent. Okay, so I have this equation. This angle and this angle are congruent. They're corresponding angles, and the lines are parallel, which means they're congruent. So I'm going to subtract 7x, and I get negative 3x equals negative 78. Then I'm going to divide by negative 3, and I get x equals 26. Okay? Then I can see that I have two angles, these two here, that form a linear pair. So I already know what x is 26. So if I do 7 times 26 minus 78, I'm going to end up with 104 degrees. Or I could have done 4 times 26. I'll still get 104 degrees. So I figured out that this angle 5y plus this other angle equal what? This one's 104 degrees. They equal 180 because these two angles form a straight line, and that means they're supplementary. So I'll solve this equation. Okay, so I subtract 104 and I get 76. Then I divide by 5 and I get y is equal to 15.2. So my answers are 26 and 15.2. And down at the bottom there are two practice questions. I would suggest that you pause the video and try these on your own. Number 1 says the midpoint of segment PT is point K. Find KT, which is this part here, if PT is 18.4 meters. Well, KT is half of PT, so you just need to take 18.4 and divide it by 2, and you'll end up with 9.2 meters. Okay, so that means that KT equals 9.2 meters. And then look at practice 2. It says identify each pair of angles as alternate interior, vertical, or corresponding. So we'll go through these one by one. Angle 1 and angle 3 are across from each other like this. They are vertical. Angle 4 and angle 8. If you consider these look kind of like window panes, 4 and 8 are in the same lower right position. They are corresponding. Angle 14 and 10 are in the same position if you consider these look like window panes. These are corresponding. And let's see, let me erase some of this. Okay, angle 3 and angle 5 are inside of the two lines, and they are on opposite sides of the transversal. They are considered alternate interior angles. Angle 13 and angle 15 across from each other, they are considered vertical angles. And that concludes our lesson for the day. Thank you so much for watching.